Next, we're going to talk about slope-intercept form. The slope-intercept form of a line is y equals mx plus b, where the m represents slope, the same slope that we just been talking about, and the b represents the y coordinate of the y-intercept. We can use the b to plot the first point on the graph, and then we can use the slope to find more points. So if I have the slope and the y-intercept in what we call slope-intercept form, all I have to do is find the m, which is in front of the x, so the m is negative 2/5 on this first problem, and the b, which is when it's in y equals mx plus b form, is just the number being added. Now, I told you that we can plot by finding the first point on the y-axis, which is the b. In this case, it's blue, so I'm going to go ahead and put a plot at 1, because this is the y-intercept, which in point form would be 0, 1. But for the b, we can just write b equals 1, which is just the y-coordinate of the y-intercept. To get more points, all I have to do is use my slope. My slope is rise over run, correct? So I'm rising negative 2, so that means I'm going down 2, and I'm running 5. 1, 2, 3, 4, 5. So I rise negative 2, and I run 5. Now I'm going to erase that because you don't really want to see that, but you're not seeing where my pencil is going as I'm drawing here. So I went down 2, right 5. I could go down 2 and right 5 more, although it would end up off my paper, correct? Now, the funny thing about slopes are you could put the negative on the top, or you could put the negative on the bottom. What would happen if I put the negative on the bottom? If I rise a positive 2, that would be going up 2, and I'm running a negative 5, that would be going backwards. 1, 2, 3, 4, 5 to the left. Is that still on the same line? Well, certainly it is. Also, is my line going downhill? And the answer is yes, it is going downhill because it's a negative slope. Let's try this again. What's my slope of the next equation? Well, it's just the number in front of the x term is the m. In this case, it's a whole number. Now, we actually like our slopes to be in a fraction form, so I'm going to rewrite this as 2 over 1. My b is just the number being added or subtracted at the end, so that's a negative 6. So I'm going to start with my pencil on the b, which is negative 6. 1, 2, 3, 4, 5, 6. Put a big old fat dot there. And then I'm going to rise 2 and run 1. Rise 2, run 1, put a dot. Now the cool thing is I can just keep going. I'm going to rise 2, run 1 more, put another dot. Rise 1, rise 2, run 1. Keep going until you're all the way off the picture to get a nice, beautiful graph. Now, if I had room, I could rise a negative 2 and run a negative 1 by going backwards. That's fine as well. Okay, next problem. My slope is negative 3, which is in front of the x. My b is 1. Slopes, we prefer having our slopes in fraction form, so I'm going to write negative 3 over 1, which could also be positive 3 over negative 1. Either way is going to work. I'm going to start by putting my pencil on the b, which is 1, and then I'm going to move my m. So I rise negative 3, which means go down 3, and then I run a positive 1. I can keep doing that, down 3, right 1, down 3, right 1. Or I could follow this instructions, which says up 3, but left 1. Up 3 and left 1. And that makes a nice, long, pretty line, so I can draw a line through it. Don't forget your arrows, please. Now, if the equation is not already in slope-intercept form, then you can rewrite the equation by solving for y. So first I want you to rewrite the equation to solve for y, then you can find the slope and the y-intercept, and then you can use those slope and y-intercept to graph. So my y is right here, and it's in standard form, not slope-intercept form. So I want to solve for y. So I need to get the 3x to the other side. I can either subtract 3x from both sides and write it this way. So that gives me negative 4y equals negative 3x plus 8. I like the x in front, so even though the x term is negative, I prefer it in the front. Another thing you could do is if you ever pick up a term and move it to the other side, by transposition, you're just going to change its sign because you're subtracting from both sides. You can do that if you want. I'll show you that on the next one. Lastly, to solve for y here, I need to get rid of the 4. So I'm going to divide both sides by 4, and that leaves me with y is equal to negative 3 divided by negative 4 is positive 3/4 x. Positive 8 divided by negative 4 is negative 2. So my slope-intercept form is 3/4 x minus 2, which leaves me with my m of 3/4, my b of negative 2. I put my pencil on my b at negative 2, and then I use the slope, rise over run. Now sometimes people are shy away from the fractions, but actually your slope wants to be in a fraction, because then you can clearly see the rise and you can clearly see the run. So I'm going to rise or go up 3 and run to the right 4. Now I could also, because negative 3 divided by negative 4 is the same thing as positive 3/4, I could go down 3 and left 4, and those are still collinear or in a line. So I can draw my line. Don't forget your arrows. Okay, so on the next problem, again I'm trying to isolate this y. So the 2y needs to stay put. I need to make the 4y go to the other side. So using transposition, just like we did last time, instead of subtracting 4x from both sides, I can just pick up the 4x, put it where I want it. I want it on the other side. But if you ever change its side, you have to also change its sign. So then I'm going to move it over and get negative 4x plus 12. Then I divide everything by 2, and I have y is equal to negative 4x divided by 2 is negative 2x. Positive 12 divided by 2 is positive 6, and this is my slope-intercept form. My b is 6, and my slope is negative 2. Now, we like our slopes to be in fraction form, so I'm either going to think about it as negative 2 over 1 or 2 over negative 1. To graph, I put my pencil on the b. I start with my b at positive 6, and then my m says to go down to right 1, rise a negative 2, and run a positive 1. I'm going to keep doing that all the way off my graph to get a really nice straight line. Or I could go up 2 and left 1. Now clearly that's off my picture, but I could also do that. Draw my line. Don't forget your arrows. So even if it's in standard form, you can still put it in slope-intercept form and use the slope and the y-intercept to graph. Now we do have some special cases. We briefly mentioned them in the beginning, where we have vertical lines and horizontal lines. So how I remember this is using Hoi Vux. It's just a mnemonic device to help me remember this. So if our slope is 0, we talked about earlier, then the line is horizontal. And as it turns out, the equation looks like y equals some number. For example, like y equals 3. But if my slope is undefined, I'm just going to write UND for undefined, then my line is vertical. Now we've talked about that when we talked about slope, but the equation turns out to be x equals some number. Notice there is no y. For example, x equals 2. I don't know, that's an example. So to remember this, I use Hoi Vux, which stands for H stands for horizontal lines, and O is not really just an O, it's also a 0, okay? 0 slopes. Horizontal lines have 0 slope, and their equations look like y equals some number. So if I can remember Hoi, that reminds me horizontal, 0 slope, y equals a number for the equation. And Vux reminds me that vertical lines have undefined slope, and their equations look like x equals some number. So here's a couple examples using this. I'm going to continue to go back to my Hoi Vux to remember which one's which. Notice that when I'm drawing this first equation, I'm looking that it only has one letter. It doesn't have two letters, so this is not going to be able to be written in the slope-intercept form. I can't find my y-intercept, I can't find my slope, because it's just not in the right form. So my y equals a number tells me it's a Hoi problem because of the y equals. So y is Hoi. So what type is this? It's a horizontal line. So what is the slope of a horizontal line? Well, the slope is 0. And in this case, if I go to -2 on my y-axis and then just draw a horizontal line, I can see that my b happens to be -2. Now technically I could write y equals 0x minus 2, so my m is 0 and my b is -2. So I could possibly write horizontal lines in slope-intercept form. Now the next problem, x equals a number, is a Vux problem because of the x. Notice there's no x and no y, so it can't be in slope-intercept form. It can't be a normal problem because there's only one letter. I know it's either a vertical line or horizontal. In this case, because of the x, I know it's a vertical line. Now the slope has to be undefined because that's what the u stands for. So if I graph this, I go to 1, 2, 3, 4, 5, 6 on my x-axis, and then I just draw a vertical line. And that's my answer. Now, what's the y-intercept? Well, it's never going to have a y-intercept because your vertical line is parallel to it, so there is none. Notice you can't actually write this in slope-intercept form because there is no y, so you can't write it in slope-intercept form, which is why it's undefined and no y-intercept. Now this one's a little bit tricky. Even though you only have one variable, it's not like equals a number. So what you need to do is spend a little bit of time solving for y. So I'm going to subtract 15 on both sides, or use transposition and just move it over. If you move it over to the other side, it becomes negative. So that gives me y equals -3. So I'm going to rewrite this as y equals -3. So because it's a y equals, it's a Hoi problem, which tells me it's a horizontal. Horizontal lines have 0 slopes. So if I go to -3 on the y-axis and then just draw a horizontal line, that is my answer. What is the y-intercept? Well, my y-intercept is -3 because you could rewrite this as 0x minus 3, so m is 0 and b is 3, -3. So this truly could be written in slope-intercept form. The only one that can't are vertical lines.